Sorry about that. I just had to do something before I hit record. So welcome back. This is class number 3 in week number 12. Crazy, hey? But we will very quickly do these answers. This is review for your test, by the way, because on your test you will have to balance equations. And then after I do these two examples, I will cut the test off here. So after this slide, like, you don't have to study anything. So this is the last type of question that will be on your test. And I mean, honestly, as far as your test goes tomorrow, it's just on balancing. So, you know, basically what we did last class and the class before will get you through this concept. So I'm trying not to introduce anything new today. I'm just going to practice some balancing, and then we'll go through some of the older worksheets, and I'll show you kind of what information you should look at, and maybe we can do some practice problems. Okay, so let me check the chat one more time. Ooh, okay. So I just had a question in the chat from Aman. That is totally possible that 3.4 wasn't there. Before I go through these answers, just let me check, because 3.4 is definitely important. I see 3.4, but yeah, I'll show you, Iman, in a minute. 3.4 is there, but I'll show you in a few minutes. Yeah, thank you, Humna. I'm going to show you where the worksheets are after this example. So let's go. Let's practice this naming business. Now, naming, or not naming, I don't know why I said naming, balancing, sorry. It's been a crazy week, crazy semester. Okay, so A is pretty straightforward. There's one challenge with balancing hydrocarbon combustions. The fact that the oxygens are split in the products can propose quite the challenge, which you guys will see in question B. Now, I wouldn't put question B on your test or final or anything, but question A is definitely fair. So the first hint I will give you, ooh, and Sophia got the answer right, perfectly right for question B. Wow, that's really good. That's a tough one. But yeah, so the hint I'll give you for hydrocarbons is balance the oxygen last. Okay, get the carbons and hydrogens sorted and then look at your oxygens. That typically works the best. So let's do this. Looking at carbons, I have 2 carbons on the left, only 1 carbon on the right. So I'm going to put a 2 here. Okay, so as of right now, my carbons are okay. Next, I have 4 hydrogens on the left, but I only have 2 on the right. So I will continue this and I'll put a 2 right here. Okay, so everything's looking good so far. I have 2 carbons on the left, 2 carbons on the right, 4 hydrogens on the left, 4 hydrogens on the right. Everything is fine, except now I need to deal with my oxygens. So let's count my oxygens here. So for oxygen, well, I guess I'm not going to write the word. I'll just put O. For my oxygen, I have 4 oxygens from the compound above, the CO2, and I have 2 more from the water. So on the product side, I have a total of 6 oxygens. All right, that's a good thing. Having an even number of oxygens makes our lives easy, because on the left side, I have 2 oxygens, which means I can easily balance that to be 6 by putting a 3 in front. So as Abdul Halim's answer that he had maybe 5-6 minutes ago, maybe 10 minutes ago, 1, 3, 2, 2. So I have 1 here, 3, 2, 2. You obviously do not need to put the 1 in there. There is a question in the chat about the final exam, which I will cover in a minute. So I'll get back to you in the chat about the final. I just want to do B first. Oh, B. B is bad news. B was a nightmare when I was a young student doing hydrocarbon combustions, because sometimes you will get a situation where the oxygen will be odd. And I don't mean odd like weird or strange. I mean odd in a mathematical sense, as in, 1, 3, 5, 7, 9, etc. Okay, let's get this started. So same method as before. I'm going to look at my carbon first. So guys, I'm down here in number B, or letter B. 6 carbons on the left, 1 carbon on the right. That's an easy fix. I'm just going to put a 3 there. Sorry, just cleaning up my notes a little bit. So 3. Okay. Oh, sorry, not 3, my brain. 6. 6 carbons on the left, 6 carbons on the right. Carbon is happy. All right, what about my hydrogen? For my hydrogen, I have 6 hydrogens on the left. I have 2 hydrogens on the right. So I can put a 3 here. That's where my 3 comes from. Okay, everything is good. I'm feeling good. I have my carbons balanced. I have my hydrogens balanced. Oh no, I got a problem. Oxygen's going to be very difficult. So, oops. Sorry, guys. Okay, sorry. I'm trying to change my pen and I messed up. Okay, so oxygens. Let's do the count. For my oxygens, I have 12 from my CO2. Now think about that. I have 6 carbon dioxides. So that would be 12 oxygens total. And I have 3 from my water molecule. That equals 15. Whenever you have an odd number, and guys, this would not be on your test this week, nothing this difficult, but this is good to know. When you have an odd number of oxygens, you introduce a problem. There is no way to put a number here that will equal 15 without using a fraction or a decimal. And we do not like fractions or decimals in chemistry. Well, in balancing equations, I should say. I've seen it in books and I've seen it on the internet, people using fractions or decimals, but that's a strange concept because you can't have half of a molecule. You either have it or you do not. So personally, or I think the way that most chemistry people would look at this is, I don't want a decimal. So what do I do? How can I make this work? Well, the easiest way to do this is to multiply it by 2. I don't want 15, but an easy mathematical trick to change an odd number into an even number is to just multiply it by 2. Any odd number multiplied by 2 becomes even. 7 times 2 is 14, right? 5 times 2 is 10. So what I'm going to do is I am going to multiply these numbers by 2. So I get 12 and 6. And now I'm going to try this again. Now, I've totally messed up the left side. Like the left side is no longer balanced, but this is going to work out to be really nice. So guys, I'm going to erase the 6 and I'm going to put a 12 there. I'm going to erase the 3 and I'm going to put a 6 there. And I'm going to start over. Again, it's like taking inventory. I don't know if you know that term. When I was a young kid, well, not that young, but a teenager, 15, 16, a lot of the shops in my town would pay us, $100 or something to take inventory, to look at all of the items after, a long weekend or something. So every time you make a change in a chemical balancing equation, retake inventory, count everything again. Because the minute you put a number in front, you've changed everything. Okay, so now let's see what I got. I got 24 oxygens and I have a 6 oxygens. Oops, I didn't mean to put the O there. So just like I suspected, now I have 30. This becomes easier to balance now. Okay, so easy way now to get this equal to 30 is I put a 15 there. 15 times 2 is balanced. Well, the oxygen is balanced. Ah, my pen. All right. The only issue now is because I've messed with this carbon dioxide in the water, I need to fix this number. And the beautiful thing here is it will work out nicely. So here on the right side, on my product side, I have 12 carbons. So I need to put a 2 right here. All right, let's check everything. Let's do it up. Let's see if this works. All right, so I have carbons, I have 12. Hydrogens, I also have 12. Oxygens, I have 30. Whew, this is guy. I've been doing this for years. This is a tough one. This is like one of the hardest ones I've seen. So yeah, not that easy. All right, what about the right side? Carbon 12. Oops, I erased my O there, guys. I don't know how that happened. Oop, put him back. For water, I have 12 hydrogens from my water, and my oxygens, I have 30. We did it. Woo! Now, again, I cannot stress this enough. You wouldn't see one this difficult on a test, I promise. I've seen your test, and for the next maybe 20, 25 minutes, I'm going to go over some questions from your test, going over some worksheets to kind of tell you what to study, and this is definitely not one of them. Question B, a little too challenging. Okay. Now, back to the chat before I get into the worksheets. What do I got here? I mean, I wish I could get rid of the O2. Like, again, the oxygen is really the problem. Okay, so Mohammed asked about the finals earlier. He asked this at about 2:45. Okay, so this is just the time we're in. So yesterday I had a meeting from my bosses. My bosses said that we got approval from the president of the college to have the finals for large sections online. The ministry, as in like the ultimate government today, literally today, sent an email to the college saying that we must have our final exams on campus. That's from the ministry, meaning like by law, by the ministry, we have to listen to them. So we cannot have them online anymore. Don't worry, don't panic, it'll be okay. We're working through, well, I mean, first of all, you shouldn't panic about the fact that it's online. All exams for every chemistry course I've ever taught have been online. The issue would be, what do we do with social distancing? What do we do with safety protocols? So this is out of my hands. The college, my bosses, the president, the people above me are going to work this out. I don't know what will happen, but the ministry says the exams will be on campus, so we have to have them on campus. Corona is still with us. That's the problem. So, there will definitely be masks involved. I'm personally, I'm going to be in the exam with you, I'm sure. I'm going to wear a face shield, but I know for you guys, there'll definitely be a rule for masks. But we'll work it out. I think it'll be okay, inshallah. So, 2 questions. Iman says, won't they change their mind? You never know. That the interesting thing about this whole process is it changes. Like in Canada, we were very low on cases and now we've exploded again. So the cities are locking down. London, in England, locking down again. We don't know what's going to happen. But as of now, the government is telling us we have to do them online. The space is an issue, but we're going to work on it. And yeah, it's everywhere. The other thing for Abdul Halim, if your math final is online. I think that will change because literally like 2 hours ago, I got an email from my boss saying that the ministry says we have to have the exams online. Anyways, it's a confusing time, but here's what I recommend. Don't worry about your final exams, okay? If they're online, if they're on campus, we'll figure it out. But as of now, they are back to being on campus. That's weeks away. Your final exam isn't until at least 3.5 weeks away. So forget about your final. Let's worry about your test. And I can tell you right now, your test is definitely online. All right. I hope so too, Bader. I really hope none of us get come down with corona before or after the final. Aman has a funny question. I don't know if any of you students have Mr. Mike for biology. Do any of you have Mr. Mike for biology? He kind of looks like me, Mike Kelly. He's got a beard, shorter guy like my height. Anyways, when we had a meeting a month ago, Mr. Mike from biology said, why don't we just do the exams in the parking lot? We'll go outside, we'll go under the under the car park shade things. Anyways, he was only joking, but that would probably be a good solution, wouldn't it? Nice and safe outside. Anyways, we'll worry about the final later. Let's get into your review here. So I'll go for 30 minutes if you want. I'll go till 3:30. I'm sorry for taking a little long to get to this point, but let's go. So I'm going to share my screen in a minute. I'm just going to go to your D2L page. Okay. So just give me 1 minute. And Aman, this will give me a chance to show you where worksheet 3.4 is. Okay, so let me share my screen here. Sharing my screen. Okay, so guys, this is my screen. Here's D2L. This is my D2L. So I'm going to pick my courses. You can see I have a lot of chemistry courses. I'll pick yours, section 1. All right, so I have some updates there. Worksheets are all available. The YouTube playlist, guys, I updated your YouTube playlist today. So actually, I can change this. I updated it maybe 15 minutes ago. So yesterday's class is on there, and I'll put today's class on there after this. All right, so to get to your worksheets, click on Content. This is the content tab. So here you'll see like your lab information, your schedule, and your lab reports, your PowerPoints and PDFs, printable notes. But what we really care about is your worksheets. And there's 38 documents in here, 38 different worksheets and answer keys. So let's start with Unit 3. So Unit 3, you guys will only need to look at 3.4 onwards. There's actually not as much as this seems. This seems like there's a lot of information, but it's not near as bad as you seem, or as it seems. The worksheets are only a couple of pages each, like 2 pages. So it's really good. Again, I saw your test and I was looking at these worksheets, and it would be very good practice. So let's start at 3.4. Now, guys, I won't have time to do every question. I'll do a couple of the more difficult ones, but really what I'll do for you guys is show you some good things to look at and to study. Like I'll give you some key questions from the worksheets. Okay, so another question in the chat there. If you, I get this every semester. If you study from the worksheet only, will it be enough? If you only study the worksheets, I could and say like you maybe mastered is a bad word, but like you really did well and understand the worksheets. So if you understand the worksheets, you could probably get 85-90% on this test. There are a couple of questions about theory that like and when I don't let that scare you, but like what is a saturated solution? What does the word soluble mean? What does the word insoluble mean? There's a few questions on that test that you might need to look at your PowerPoints, but just remember, your test is online. You have 2 hours. You can look things up. So if you can't remember what insoluble means, you can find it in chapter 4. If you can't remember what a polar molecule is, you can find that in chapter 3 or unit 3. So if you really, really did well on the worksheets, you could easily get an 80, 85, even a 90 on this test. Okay. So question 2, obviously a good question. Question 1, not really, no. Question 1, I wouldn't worry about. But question 2 on worksheet 3.4 is kind of important because there are questions on your test where you'll have to talk about polarity or shape, which I'll do a review of this today. A little reminder though is because you're doing this test online, there's no way on D2L to draw these molecules, like for the students. So while this is a good question, you won't have to draw them, but you should know what they look like. So let me just see. I think there's a question I did today. Yeah. Okay. How about this? Let's do a very quick review of PF3, and then I'll show you another good problem to practice. Okay, so PF3, let me zoom in a little bit. Now, again, you will not have to actually draw this on the test, but you will need to know the shape for the polarity and VSEPR, which I'll get to in a couple minutes. Okay, so PF3. P is in group 15, F is in group 17. So P has 5 electrons, fluorine has 7 electrons. Sorry, we call them group 7A or 5A or 17 or 15. So phosphorus P 1, 2, 3, 4, 5. Fluorine has 7. I'm going to erase fluorine in a minute and I'll show you why. Think about this as a puzzle. I have 1 phosphorus that wants 3 bonds. I have 3 fluorines that want 1 bond. Like, these molecules do this for a reason, right? The reason I'm writing PF3 is because it's a perfect match. These chemicals are like really, really compatible, right? They want to be together. So how do we put them together? Well, because I have 3 fluorines, I'm just going to put them around the phosphorus. Now, if you were looking at polarity or intermolecular forces or the shape of this, you're done. You don't need to do anything else. I know that I have a lone pair and 3 bonds. If you want to be really fancy, you could put these around these electrons, but you don't need to. I will come back to this, guys, in like 5 minutes, because after this, I'm going to explain how you could find the intermolecular forces and shape, which is definitely test questions, multiple choice question. What is the shape of this molecule? A, bent, B, linear, etc. Okay, what else from this slide is good? So question number 2, definitely, or from this worksheet, sorry. And then question number 5, I wouldn't worry about questions 3 and 4. There's no naming on this test. So I would then try question number 5. You will definitely see something like question number 5 on your test. So how do we do it? It's been a few weeks, maybe a month. How do we calculate if a bond is polar? Well, easy, I think. What we do is we look up the electronegativities. Okay, you look this up on your periodic table. So oxygen, now I'm opening up my periodic table. you guys, the periodic table, you can still pick it up outside my office, but if you're not on campus, you can just grab or look at the periodic table in D2L. I have it under content. So on the periodic table, it tells me that my electronegativity for oxygen is 3.4 and my electronegativity for hydrogen is 2.2. So the difference in electronegativities is the subtraction of them, which is 1.2. And the rule is if the number is bigger than 4, or sorry, bigger than 0.4, it is polar. All right, cool. Now, this part over here, this isn't really that important, but what this means is the more electronegative element is negative. The element that contains or has the element that has the highest electronegativity, we would say is partially negative. This word means partially, or this symbol means partially negative. It's not fully negative. Remember, these aren't ionic compounds. It's not an ion. It's just slightly negative. Okay, so that's worksheet 3.4. You should know questions 2 and questions 5. If I'm going too fast or you don't have enough time to write anything, this will be on YouTube by like 4 o'clock today, so within an hour. I'll upload it after class, but it takes YouTube like 15 minutes or so to like render the video to get the video. Okay, let's look at worksheet 3.5. The answers are here, by the way. So you can always check your answers when you're done. All right, 3.5. I won't really go over chapter 5 very much because we literally just did chapter 5, but I will kind of tell you what things to look at for sure. Oh, okay. So Abdul Halim. Abdul Halim's question was, I forgot to go back to PF3 to check intermolecular forces. I'm going to do that in, I think, worksheet 3.6. Okay, worksheet 3.6, we're going to look at PF3 and the intermolecular forces. Okay. No problem. The way the worksheets work is like they're just like your class notes. So first in 3.4, we looked at electron dot diagrams and polarity. In 3.5, we looked at VSEPR shapes. In 3.6, we looked at intermolecular forces. So I will come back to that. Okay, guys, question number 1 is good. I'm going to review question number 1 in the next section, but definitely know question 1. But I will review this in section 3.6. I'm going to kind of review the whole concept of intermolecular forces. Remember, these are intermolecular forces. Polar is dipole-dipole. So I'll get back to that one, but I would definitely look at number 1. I would also look at, more importantly, question number 2. Now, again, you cannot draw this on your exam. We don't have the technology. D2L just doesn't really let students draw. Not that I know of. But you might have to know elements bonded, the name of the shape, or lone pairs even. So let's do one. Let's do a different one. So instead of doing PF3 or PCl3, they're the exact same, by the way. One has F, one has Cl. Let's look at OF2. Excuse me. Okay, so O, group 6. Hold on, let me zoom in here. Make this a little bigger for us. Well, more for me than anything. Okay, so do question 2, OF2. O is in group 6 or 16. It has 6 valence electrons. It would look like this. Again, you do not need to draw this. Now, F has 1, so I can put my F here. You can fill it out if you want to. You don't need to. It's actually less confusing if you don't fill the F electrons in. But anyways, I'll draw them really small. All right, let's pick a different color. Okay, so elements bonded, lone pairs, name of shape. First, now, I don't need the data book yet, but the elements bonded are easy. This is always, whoa, I meant to do this. This is always on your central atom, always. So my elements bonded, I have 2 elements bonded to my central atom. I have 2 fluorines. My lone pairs, I have 2 lone pairs. Okay, now I need to know the name of the shape. Now I know the name of this shape because I've unfortunately been doing this for 10, 12 years. You guys might not know the name of the shape, but that's cool. That's okay, because you know what? We got a data book for you. So I'm going to open up the data booklet. I'll share my screen and I'll show you where this information is found. So where do you find this information? Well, it's on page 4 of your data booklet. Your data booklet, wonderful document, tells you the shape of molecules, and you only need to know the top half of the table. Oh, and sorry, when I say you only need to know, you don't actually have to know it. You just need to know how to use it. So here I have bonds and I have lone pairs up at the top, and I have the shape. I even have a little sketch of the shape. So clear my drawings. What do we do for the molecule I had? I had OF2. It's not clearing. Oh, I'm dumb. I was wondering why it wasn't clearing my drawings, but I'm in a different app. Okay, sorry. So I just found out that my molecule had 2 bonds, 2 lone pairs. So my shape is bent, and I could sketch it like this. All right, that's it. So let's go back and sketch it. So it's bent, and there's my shape. Now, you guys, again, I've said this like 50 times, you do not need to sketch any shapes because we don't have the ability to sketch any shapes. So let me go back to my notes. Here we go. Okay, so OF2, let me just draw that again really quickly. Okay, there's OF2, 2, and 2. The name of the shape is then bent, and the Vesper shape, which you don't need to know for right now, but it would look like this. Oops. It's a 3D shape. Cool. All right. So there you go. I think that's it for worksheet 3.5. Yep, that's it. Okay, and again, remember, guys, this is what you need to know, the stuff in the middle. All right, let's look at another worksheet. I hope this is helping. I hope this makes sense. I don't think your test is anything to really worry about. Inshallah. It looks pretty easy, but I mean, I'm not really a good fair representation of that. Okay, so this goes back to Abdul Halim's questions, or Abdul Halim's question. What about the intermolecular forces? So what I'm going to do, I'm going to, well, hold on, let me see what do I want to do? Okay. Well, first of all, okay, let's do this first. First, these are the good questions you should know. You should definitely know number 1, how to list the intermolecular forces. You should definitely know number 3. I mean, really, you could know the whole thing, but okay, if I could rank them in order of importance, questions 1 and questions 3 are definitely the most important, and it wouldn't hurt for you to practice the other ones. Okay, so let's do question 1. But question 1 and 3 would be my main focus. Now, I told Abdul Halim we would look at PF3. Well, let's look at NH3. It's pretty much the same thing. I mean, I can look at PF3 as well. Why not? I'll do it over here. Okay, so there's PF3. We'll look at that one in a minute, but let's also look at NH3. Okay, so intermolecular forces, there are three types. There are London dispersion. Everything has London dispersion, everything. So this has London dispersion. This has London dispersion. Okay, so that's easy. What about the other forces? Well, the next force is dipole-dipole, which is basically, is the molecule polar? This is probably the hardest force to understand. Dipole-dipole happens when there are three situations. Okay, so is it polar? Well, it's polar if it has three or more elements. It's polar if the central atom has a lone pair. It's polar if there is no central atom and there are different elements. Okay, those are the three questions you need to ask yourself to figure out if something has dipole-dipole. Okay, so let's look at these molecules. NH3. Are there three or more elements? Absolutely not. You might think there are because you're saying, well, there's a nitrogen and there's three hydrogens, that's four. No, 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 no. Three or more different elements, okay? Sorry, actually, that should be, I'm sorry, it should be, no, that's right, two, three or more. I was gonna say two or more, but no, it is three or more, that's correct. So none of these follow that rule. Each of these chemicals only have two elements, nitrogen and hydrogen, phosphorus and fluorine. Okay, so that doesn't apply. Question number 2, does the central atom have a lone pair? And in both these examples, the answer is yes. Both of these central atoms have a lone pair. This guy and this guy. So these are both polar. These have both dipole-dipole intermolecular forces. DD means dipole-dipole. LDF means London dispersion. All right, I got the chat's going crazy up there. So let me just get actually, no. Let me answer the chat first, and then I'll get into hydrogen bonding. Oh, Naval, you can go. Good luck on your test. Sorry, you wrote me privately. If any of you guys have to go early, this will be on YouTube in maybe 40 minutes, 30 minutes. So for anybody who has to leave early, just go. No problem. I will put this on YouTube after. The other question or other thing I'll say is if any of you have to go, but you really want to ask me a question, send me an email or something tonight or tomorrow morning, and I'll get back to you. Okay, so back to this example. Thank you, Hamza and Naval. And again, make sure you check the ending of this video. This would be class number 3, week number 12. Okay, so check out this last video to get some more hints. Okay, last one, hydrogen bonding. And I hope I see you guys in the lab as well. Okay, well, I'm kind of spoiling the answer. Does it have hydrogen bonding? Now, remember what hydrogen bonding is. Hydrogen bonding is when you have hydrogen bonded to F, O, or N. Okay, well, this definitely has hydrogen bonding. The nitrogen is bonded to hydrogen, or I should have said the hydrogen is bonded to the nitrogen. This definitely has all three intermolecular forces. PF3 has no hydrogen bonding. There is no hydrogen there. The follow-up to this question, and I'll ask you guys this in the chat if anybody's still with me, which of these chemicals would have a higher boiling point? NH3 or PF3? Which would have the highest boiling point? Fahad answers in the chat. Thank you very much. NH3. The reason NH3, Abdul Halim, just you took the words out of my mouth. NH3, the reason NH3 has the higher boiling point is because it has hydrogen bonding. It has all three intermolecular forces. Okay. I'm getting really low on time, guys, so let's look at a couple more questions and then that'll be it. Now, I have good news, and this is not good for the people who have already left. We didn't do the last section in chapter 3. So you guys, you do not need to look at 3.7. You can omit or just ignore 3.7 for now. I'm thinking at the end of the year we can go back to this because it's not related to chapter 3. It's about acids and bases. So we can do that a little bit later if we have time. But you can skip you can skip worksheet 3.7. We did not do it. All right. It's there though if you want to look at it, but I wouldn't. Okay, chapter 4. Now, chapter 4, let's look at a couple of these worksheets. Let's start at worksheet 4.1. It's not in the test, Aman or Mohammed. Do not look at 3.7. It is not in the test. Okay. Now, I am very low on time, so what I'll do is I'll kind of tell you what to know. Honestly, guys, I would know section or like do all of worksheet 4.1. It's good practice. Worksheet 4.1 are calculations involving atoms and moles. So it would be this formula. Okay, I won't really I'll do one of these in a minute, but I won't do all of them. I'll pick a more difficult one to try, but yes, you can do all of this. The answer to number 1 is not on your final exam, but it's carbon 12. Or sorry, it's not on your test. But I would do all or look at all of worksheet 4.1. It's only a couple of questions and it's just really good practice. Okay, so I would look at the, formula, units, moles, easy. All right, let's look at 4.2. 4.2. I think this is the molar mass one. Yeah. Okay, this is a good one. 4.2, definitely no 4.2. Again, I would look at most of this worksheet. This is a worksheet where you're going to calculate molar masses. Then you're going to do molar mass and mass calculations. Now, there's a million practice problems here. You don't need to do all 10 of these, but I would practice a couple of these for sure. Okay. So again, worksheet 4.2, you could look at the whole thing, but it's just practice problems about the same thing. So let's just do an easy one just to remind you of how this works. And I'm almost done, guys. Okay, what is the mass of 4.2 moles, 4.12 moles of iron? Well, that's pretty easy. I picked this one because it is easy. Iron is Fe. So to find the mass, I use my formula from my data booklet, moles times molar mass. So I take 4.12 moles and I multiply it by the molar mass. Now, the molar mass, guys, is the sum of all of the masses in the compound or element or whatever it is. So like if you look at the next page here, this example, if I wanted to find the molar mass of this, I would do, I would add together Cu, 2 nitrogens, and 6 oxygens. For iron, I don't need to do anything but write down the mass of iron. Okay, and then you would get your answer. That's it. That's a really good test question. Wink, wink, wink. Good multiple choice question. Calculate the molar mass and then multiply them together. Thank you, Aman. Sorry that you have to leave. Have a great day. I'm almost done. I'm going to be done in like 3 minutes. So make sure you check the YouTube video after. Have a great day if you have to leave. All right. Let's look at another worksheet. We just did 4.2, so let's look at 4.3 and 4.4. Now I think we're getting into, solutions. This is a good practice. I would again look at most of this worksheet. I would look at all of it, to be honest. Worksheet 4.3 is really good. Worksheet 4.3 and 4.4 is like a study unit. This would kind of cover a lot of the information in your notes. Like this is actually a great worksheet because it tells you definitions of words like immiscible and miscible, soluble, solute, solvent. Definitely look at this. Now, I'm not going to explain to you definitions, so I'm going to move on. These questions, these word questions, you can try on your own. The answers are there. And this one, solubility, definitely know how to do this. For these questions, we did it in the lab, but for these questions, you need to use your solubility chart in your data book. Before I move on, does anybody want me to show them how to do solubility, or are you guys okay? Thank you, Humna. Have a great day. Good luck with your test if you have one. So does anybody want me to show them how to use the solubility chart, or can I move on? And I honestly do not mind. No need. Anybody else? I'm done for today. I have infinite time. So I don't know what emoji that is. It looks like a little balloon. I'm sorry, Mohammed sent a little emoji. Okay. All right, I'm gonna move on. I can't see it. Do you want me to look at solubility, Mohammed? It'll only take me a minute. Do you want me to do that? Yes or no? I don't know. Okay. No, okay. Sorry, I'm using my computer screen. You guys might be on like Android or Apple, like iOS, but on my computer screen, that emoji is like, it looks like a little balloon, a little circle. Anyways, all right. Here we go. One more worksheet in chapter 4. Whoops, I didn't mean to do that. And then I'll just tell you about chapter 5 and we're done. All right, worksheet 4.5. Worksheet 4.5, you might see one or two of these. Well, okay, worksheet 4.5, you will see some of these questions. For worksheet 4.5, we just did this in the lab, literally this week. So I don't think I'm going to do too much of a review here, but you guys are expected to know, wink, 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 winky face. You are expected to know how to calculate the concentration in molarity, which is moles per liter, in percent, and in parts per million. Okay, so we did these in the class, so there's video of this. It's in your notes and it is definitely on this worksheet. So make sure for tomorrow, they're very simple, but make sure you know how to calculate the concentration of a substance in molarity, percent, and parts per million. Wink, 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 wink. All right, I think I'm pretty much done. I'm just going to do one more thing. I'll just remind you of what we did in chapter 5, and then halas, we are finished. So chapter 5. Now, guys, for chapter 5, give me 1 second here. I just want to check something. Okay, for chapter 5, you can get away with the first 2 worksheets. Okay, these are on balancing and equations in general, as in like products versus reactants. You will have a couple of questions where you'll have to balance something, or you might have to tell me, what are the products, what are the reactants? Very easy. This section here, we didn't get to finish in class. We're about 1 class away. So this is all about chemical reactions, types of chemical reactions. The only 3 chemical reactions you need to know are decomposition, composition, or what we called it combination, sorry. And combustion. Now, obviously, you guys can't, write full chemical equations very easily in D2L. So these questions are multiple choice, meaning I will give you a reaction and ask you to tell me which is, like here's a chemical reaction. Is this reaction decomposition, combination, or combustion? Or I'll give you a list of chemical reactions and say, which one of these is combustion? So just a reminder, decomposition, 1 element breaks into 2 or more. Combination, 2 or more elements combine to form 1 compound. And combustion is when you burn a hydrocarbon, CH, in the presence of oxygen, and you would get carbon dioxide and water. Vincent, I am finished. Halas, I am done. Thank you so much, Vincent and everybody else. I will see you guys. Well, I'm done. I shouldn't say I'll see you guys later. I'm going to hit stop record. If any of you guys that are left have questions, let me know. But I'm going to stop the YouTube video for now. And again, if any of you want to ask me anything, literally, if you want me to do any type of example, I can show you.